Okay, I guess everyone already answered the question. So we'll start our event now for today. For our event today, we invited our speaker Tunan to okay. Tunan is a founder at GDSC, Moffitt Community as ambassador. Now he's currently working as a software engineering in 𝐼𝐴𝐴𝐵𝐻. So let's welcome Tunan. Continue this event. Hi everyone. Nice to meet you guys. Welcome. And just a show of hands, right? Who is the first time listening to this talk? Okay, let's put it this way. Who is not the first time? Not the first time. Not the first time. Okay. Okay. So yeah. Thanks to GDSC UTEM for inviting me back again. Thanks for Arwin for hosting this and also all of this slides. So first is asking you guys, right? What is Git? So somewhere we can store our coding and can retrieve system that controlling commit file. Not really correct, but the idea is there. The word is there. So the more accurate one is actually the version controller for not file system, but it's version control for code actually. Usually used by programmers. Yeah. So where the magic begins? Yeah, I like this answer. So yeah, I think you guys have quite the idea of what is Git. So maybe later I can go through it more quickly. Yeah. So let's see. Next slide. How do I click next? Yeah. So how do you code projects or assignments? So get idea using Eclipse. Oh, we have a Java programmer here. Okay, coding using Visual Studio. It's a very common one. Upload to GitHub. What's GDB online? No one? Mostly using ChatGPT. Come on lah. Send code through Word file. Okay, please don't do that after you learn Git. This is a very bad practice. Don't do that. So yeah, so after today, I think you guys will know how to start a project in Git, how to collaborate with people using Git, and make your assignment much more easier. How do you back up a project code? Upload on cloud, save as extra file, saving project, saving document, backup on Git. Okay, I like this guy. Using pen drive, saving in OneDrive. This is a very old-fashioned way. Save in a Word file, save in Git. Come on. Okay. One participant typing. Okay, let's just wait. This guy. Save at OneDrive and computer. Okay, this is a very common way. So I won't judge. Yeah, it's a common way, I would say. Okay, so let's go to our presentation then, the main event for today. So, where's my mouse? Sorry. Okay, so actually the main name for this event, like when I did the slides, right, it's actually GitHub and 𝐺itkraken. So since then I've graduated UTEM and I've been working already lah. So now I'm a software engineer at Infinite 𝐶𝐵𝐻. Yeah. see the slide? Sorry, technical error. Um, this is a very weird situation. Hmm. Okay, let me just change the setting. I'm so sorry. You can see. Okay. So yeah. Okay. So all of you guys have a GitHub account right now, right? All registered. All installed Git Kraken, and I assume you guys already logged in Git Kraken. Not yet. Never mind. Yeah. Okay. So yeah. So just a disclaimer before I start this thing, right? So if there is any opinionated statement regarding anything, so it represents me, it does not represent the SC, and everything here is for educational purposes. So if let's say you try to use Git and hack UTM server, it's not my problem. Okay. Okay, so housekeeping. Before we start, so there will be a Q&A session at the end. So please take note of your question. I won't bite. I don't eat people. And then there will also be an extended session later on to cover more advanced topics lah. Uh, usually cater for those that are more experienced in Git already, or if you or you don't have any experience, you can also use it to see the potential things that you can do. No, like Okay, and also the slides will be shared after the event, lah, so you don't need to take out your phone and capture everything. Okay, so the agenda. So, of course, I will start with a brief history of Git and the software management tools. So there are many different tools, not only Git, but there is a reason why Git is one of the most prevalent management software, and you will see from later on. And then I will continue with some simple Git operations and concepts, and then after that, I will go into the Git Kraken, GitHub, and then why I chose Git Kraken as one of the entry points for all of you to learn Git. And then of course there will be demo and also a Q&A. So extras, so we will do it if we have time, is how to make sure everyone contribute in your assignment, because all of us hate assignment freeloaders, right? And then underlying mechanism of Git if time allows, and also GitHub Actions. This one will be in the extra session, the extended session. And then also how to make your GitHub profile more appealing to recruiters. Okay, so let's start with the problem. So I like to approach everything with the problem first. Okay. So the problem is when you do assignment, right? This will be your naming way lah. So you will say final, okay, final, final, final. Really, really final already. So in the end, you end up with a bunch of files that you don't need, right? So it is also very difficult to keep track of the work done because, for example, oh, okay, sorry. Okay, so it's very difficult to keep track of work done, right? So let's say you are a group leader, and then you will need to assign people to work on different tasks. So when you work on different tasks, for example, when team member one sends the code in, and then you need to review, you go to merge, and then you tell group member number 2, 3, 4, 5, 6 that we got these changes, and then those team members they got their own changes, and then you need to merge and everything. So in the end, group leader is not a group leader; it's called a code merger. Okay, it's no longer a group leader anymore. Okay, so uh, multi-people projects, well, it is held without proper tools because why? Maybe you realize your current code is screwed up. You don't know where you edited last. You don't know when it works last, and then you want to go to a previous version. Happens all the time. Okay, and then how do you keep track of changes from version A to B? Right? Let's say from version 1 to version 2, you want to know what changed. If you don't have this kind of tracking system, how do you want to keep track, right? And then what happens if your computer explodes when you compile the last version of the FIP? You'll cry, right? You cannot even graduate anymore. So if something happens to your code, so there is a real story, right? There's this guy, he made a trading system, automatic trading system lah, by using AI, so it will automatically trade or when the price is low buy, when the price is high sell. So what happens is, just before the meeting with the investors, his computer screwed up. Everything gone. So everything that he has done for the past 2 to 3 years, all gone. Yeah. So this is what happens when you don't really back up your code lah. Okay. So yeah, this is what happens when you don't use proper version control. As you can see, this is actually live code lah for at least for year 2019. It's in one of our UTEM systems lah. You can go check around if you want. Okay, so in the end, you as a group member, you as a group leader, you will say what what is happening right now. You don't know what goes where. You don't know what does what. So yeah, so there comes software configuration management tools, or we call SCM tools lah. So we have three types of repositories. One is local, central, and distributed. So Git in general is a distributed repository. So local repository is what you save in your local computer, and it only lives in your own computer. While centralized repository, it saves at a central space. Distributed is like everyone has a copy, and if let's say someone screws up, you can always just delete your own copy and restore from what we call the source of truth. So the source of truth in most of our software cases is GitHub. Okay, so version control in general there are two types: centralized and distributed. So centralized, you need to be connected. You screw up when your server screws up because everyone connects to that server, and then it will be good for binaries like images, videos, CAD files, CAD files. The good thing is it has central safeguarding. So let's say if person A does not work anymore, you can always kick them out immediately. Okay, distributed, you can work without being connected. For private work experimentation, you can always make your own branch. You can always make a copy at your own local computer, and break things. It won't break the main place, and then it prevents a single point of failure. So, like I said, you screw up when your server screws up if it's a centralized, but distributed. If let's say your computer explodes, you can just copy from your team member and just continue, or you can just pull from GitHub, and that's it. Okay, but distributed is bad for non-modular files. For example, binaries like images, videos. So if let's say if you use a text files, right? Those text files, they will have this thing called a diff, which is in math we call it a delta. So what changes? What is being added? What is being subtracted? So binaries, they don't really have this capability. So in the end, what will happen is you will have multiple copies over and over again. So for example, you change maybe a single thing in your video file, you copy the video file all over again. So you do 10 versions, one video file 2 gigs, you get 20 gigs already. Okay. So version control software, of course we have Git, we have Bitkeeper, Subversion, Mercurial. All of these are not really commonplace like Bitkeeper. So both on the left, that is of course Microsoft 365 and G Suite. Those are actually version control software also. The difference is those are centralized and Git is distributed. So version control software is not limited to the software world only, right? Okay, so why we learn Git is because that is what the majority of people use anyways, and it does not really break. Yeah, it does not really break. Principally, yeah, by principle it does not break. Okay, so what is Git? I talk so much about Git. So the Git official page says that it's a free and open source distributed version control system to handle everything from small to large project with a really good speed and efficiency. So you can see many of the big projects, right, use Git. For example, Android, Linux, all of those really big projects. So you can see how robust this particular software is. So a brief history of Git. So again, just like many different softwares, it is frustration that change the world. Okay, so some background knowledge. This guy is called Linus Torvalds. He's a software engineer. He's born in 1969 and released the Linux kernel in 1991. So what is the Linux kernel? Is basically, you know, it's a software layer that allows the software to talk with the hardware. So that is the kernel in layman terms lah. So Linux in 2002, it's one of the largest and the most active project in development. So you can imagine 400 plus developers in the contributors file, and those many different developers that are not listed. So you can see how big the project is, and it has about 3 million of estimated lines of code. So you can see from this graph lah. So this small little line here is 2002, and you can see the number of code, the lines of code keeps increasing. Okay, so initially Linux used a Bitkeeper, but this guy called Larry, he pulled out and said that, okay, I don't want to let Linux use anymore because this particular guy go reverse engineer my software. So Linus Torvalds, he goes set out to find a replacement. Had fast patching, distributed parallel workflow, and very strong safeguards. So him being the legend he is, he wrote Git over the weekend because he was too bored. Yeah, so the criteria is that each patching should not take more than 30 seconds. In general, at that time, software used about 30 seconds, and each synchronization, needs about 250 of soft actions, and then you need a distributed and parallel workflow. Everyone can work at the same time, and most importantly is that it need a very strong safeguard. So how to prove that you are you, and how to prove that the software is what it is. Okay, so what does Git stand for? Because programmers, they spend a lot of time coming up names. Okay, so according to Linus, depends on your mood. If you say the official so-called definition, it's a random 3-letter combination, and then a stupid content tracker. Stupid as means that very simple. Okay, and then if it works, it's called the global information tracker. It tracks everything. And then if it does not work, it's called a goddamn idiotic truckload of shit. Yeah, you can see I didn't make it up. You can go find the Git repository in GitHub, and this is what it says. So yeah, after that, Linus Torvalds said that, okay, fine, I don't want to manage, I don't want to maintain this. So I passed to this guy called Julian Hamano. Yeah, he's currently employed by Google. So side note, so Bitkeeper went open source in 2016 and basically stopped development now. Okay, now comes to theory part. Okay, so some simple Git operations and concepts. Okay, so first questions, repository, remote, branch, commit. These are terms that you will basically use every day when you use Git. Okay, so first term, repository is the place where you place your code and everything that comes with it. So for our context, let's just define the repository as some place on your computer. Okay. In different contexts, they will mean different things, but in current context, let's say that repository is your local. Okay, and the remote is a Git repository that acts as a source of truth. So, for example, a server or GitHub, we call it a remote because it's remote lah. It's not on your computer. So usually refers to a centralized server, or sometimes we call it the origin. Okay, and branch, a mover reference to a series of commits. So branches will move as you commit. So you'll move. And then if you do more in-depth software development, you will see that there are two major types of branches, volatile and stable branches. So if you fork a code, you create a branch. Okay, this is very simple. So tag is a fixed reference to commit. So for example, you want to release like version 1. So this version 1, you cannot make it change because you add commit, right? So you say that, okay, version 1 is this commit, this particular commit here, until this commit is version 1, and it doesn't move anymore. Okay, and then I said commit. So what is a commit? So basically a commit, you can think of it as a snapshot of the code at that point in time. It's basically you save, yeah, that's it. So what Git does is that it saves a version of the code every time it is committed. So you will have multiple copies of the same code, and it will be easy to trace back. And then a hash will be generated based on the root commit. So if you don't understand this, never mind. Later on, I will use Git Kraken to tell you guys lah, like what is what. Okay, so a file life cycle. The file starts with being untracked, which means that Git does not know its existence. So now you stage it, you add a file, you stage it, you put it at a place that you know we call it the staging. So basically anything that goes into staging, right, will be committed when you commit. So you can see here when you stage it, you commit here, and then it becomes an unmodified file. It's not an untracked file anymore. It is an unmodified tracked file. And then when you edit the file, it becomes modified. You stage the file, and you know it basically these cycles go over and over again until you remove the file. It becomes untracked. Okay. So why use Git? So Git gives a complete long-term change history of every file. You can log the changes in a very good and searchable way instead of you need to rename the file for each and every version. And you can branch and merge. So for example, your version of code, you do this, and then your team member can do his part or her part, and then the other team member can also do that. And then in the end, you guys only decide, okay, let's merge it, let's put it together. So from the demo later on, you can see that we will have a very simple and nice view on viewing these kinds of changes lah. And then the most important thing is traceability. We need to know who did what when, and if it's a malicious commit, how do we block? Maybe we can say, okay, block this email address and so on. And of course, immutable. So immutable means that you cannot delete it from one place. You cannot really change it from one place. You need to change every single place, which is nearly impossible. Why? Because Git, it employs a mechanism similar to blockchain to prevent changes to the history, and everyone has a copy. So how it hashes is not in the scope of this talk, so let's just leave it as like this. Okay, so I finished talking about Git. Now I talk about Git Kraken. So why do I use Git Kraken? Previously, Git Kraken, this company, they have 3 software, but now they shut down the other 2, so now it's left with Git GUI. And then why Git Kraken? So Git is very powerful, but imagine every time I want you to commit something, you need to type all those things on the right. It's very tricky to visualize, it's very time consuming, and of course if you are a beginner, right, you see all these words, you're like, what is happening? Is unpacking project so okay? Or maybe sometimes it will say, okay, merge conflict. Oh no, merge conflict. What do I do now? Right? So for beginners, we recommend using a GUI. So for me, I recommend Git Kraken. It gives a visual interface of enabling the same workflow with only a few clicks. So in the end, actually, right, when you go to work and stuff, you will eventually graduate, so-called graduate from 𝐺it-Kraken and only use some few small VS Code extensions. So for like me, I'm not using 𝐺it-Kraken in my work anymore. I use different VS Code extensions to help me with my daily work lah. So yeah, there will come a time where you graduate from 𝐺it-Kraken. I said that. Okay, alternatives to 𝐺it-Kraken, like what I said just now, we have 𝐺itcraft and 𝐺itLens. So why don't we use 𝐺it-Kraken in corporate environment? Because corporate environment code is private, and 𝐺it-Kraken license does not give you to use private code for the free license. Yeah. Okay, GitHub, and as always, a slight history about it. So this particular mascot is called the Octocat. It's an octopus and a cat. Okay, so GitHub launched in April 2008, acquired by Microsoft. So now it has about 100 million users and about 400 million repositories estimated. And then it hosts or as an archive mirror, which means that it makes a copy of a significant number of very important projects like Kubernetes, Git itself, Angular, and so on. Python is also there. So it launched a GitHub archive program. So what it does is that it takes a snapshot of all your code and then it puts it in the vault so that one day if let's say humanity cease to exist, our code still exists. Okay, so GitHub being a site it has quite a number of notable services. So as what we know, GitHub has code hosting, you can do documentation there, you can do discussions, and then graphs. This graph is one very important thing, especially when you want to calculate who contributes most in your group project. Yeah, it's a very nice feature. And of course, we have GitHub Copilot. So what GitHub Copilot is basically your code assistant. It's like ChatGPT, but for your code. Yeah, it existed before ChatGPT, but it uses the same underlying technology as it. And then we have GitHub Pages, which is basically a static website you can put. Gist, if you guys know Pastebin, it's a GitHub version of it. Security alerts, like let's say someone can hack you, blah, blah, blah. GitHub Actions. Okay, GitHub Actions will be in our extended session later. And the next is GitHub Code Spaces will also be in our extended session later. Okay, so stay tuned. Okay, alternatives to GitHub. I like to give alternatives because it's not one single thing only. So we have GitLab and also Bitbucket. So why GitLab and Bitbucket suddenly has so many users is because that time Microsoft bought over GitHub and people said that, oh, Microsoft will shut down GitHub, blah, blah, blah. So they shift to GitHub because they don't like Microsoft. Yeah. So in conclusion, just to not mess you up, Git is the version control system. GitHub is the place to host your code and potentially perform CI/CD stuff. And 𝐺it-Kraken is basically a GUI interface for Git. Okay, now it's demo time. So quickly demo time already. Okay, so hopefully I don't break your computers in the process. Okay, so demo session housekeeping. So if I'm too fast, tell me. And I can't guarantee to respond to all due to time constraints. And yeah, here's our agenda. So a basic overview is we will start with creating or forking a repository or a project. And then I will talk a little bit about git-ignore. This is a very important file. And of course, we also do copy and clone the repository. We add a file to a local repo or commit the changes. We push the changes, and then we make a change to the file on GitHub. Yeah, and then we commit that. So when we pull the changes in, we can make a merge conflict. A merge conflict is a very common issue, but with enough knowledge, you will know how to resolve it. Okay, so we can pull the changes to local machine and then open a pull request and then merge your branch to the master branch. Okay, so in many references, you will see that, oh, this is called the main branch, this is called the master branch, right? It actually means the same thing. So why master branch is called the main branch is because a few years ago, there's this movement called BLM movement, Black Lives Matter movement. So they say master this term crime is slavery, so they call it the main branch. Yeah, so weird, right? Okay, let's start with demo, I guess. Let's start with 𝐺it-Kraken. So because I didn't use 𝐺it-Kraken already for quite some time, so I just reinstalled. So those of you that initially install also, let's sign in. Sign into your GitHub account here. Okay, so should be signed in. Wait a while. Yeah. Okay, so actually 𝐿𝐿𝐴𝐾𝐿𝐿 is very good is that it automatically detects your author name and your email. So if let's say you use a normal Git or you use a GitHub CLI, right, it doesn't automatically detect that, and you will need to manually tell it who are you. Okay, so I use it for Git commits. Okay, and okay, so before I continue, right, this is the demo step on forking. So you guys can access this particular link here. You guys got that link? Or you guys want a QR code? Oops. Yeah. Anyone using a phone? So just open the uh, website on your laptop. Sorry. Okay. So once you get in here, yeah, I forgot something. Let me make my cursor larger. Okay, this is good enough. Okay. So let's start with forking. Okay. So what fork does is basically you make your own branch of this particular code. So it's very simple to do. You just click fork here, up here, okay. And then usually if you are new to GitHub, there's only one account, but as you can see, I have many. So you choose a repository name and you can say, okay, remember to untick this. Don't copy the master branch only, okay? Because we need a few different branches to do what we want to do. Okay, so create fork. So it's making a copy. Okay, so now you can see that this particular repository is now under your name. Okay, you can see it's forked from this repository, so you can always track back where is your source repository. You guys good? Not good? Good? Not good? Raise your hands if you are not good. All good? Okay. So what do we do next? We come to 𝐿𝐴𝐾𝐿𝐿 and say that, okay, I want to clone a repo from the internet. Okay, so let's clone the repo, and you can see here github.com, and because it's connected to your account, right, you can always look at which remote you want to clone. So for here, you can see learn git if 𝐿𝐴𝐾𝐿, right? So you just search learn git if 𝐿𝐴𝐾𝐿, and you click it. So weird. Okay, and then after that, you choose the location where you want to clone to. So where does this code live on your local computer? Okay, so you click on browse. And for me, I will usually open a folder called git code, and then I just throw everything in here. As you can see, my different projects here. Okay, you select. Okay, so you can see the full path is what you inserted here, and then it will automatically create a folder for this particular repository. Everyone good? Good? Not good? What not good? Oh, you can't see. Okay. I'll say it again. Okay. You guys can see from behind. Can already? Can? Okay. So step one, go to this website. Okay, github.com, Exosoft, learn Git with 𝐿𝐴𝐺𝐿. All good? Step two, click fork. Okay? Basically saying that make a photocopy of this particular code. Okay? You create a fork, choose your owner, repository name, and you can choose to copy the master branch only or not. But usually I will copy all the branches lah. Okay? Then after everything is done, click create fork. Okay? All good? Okay. So once you create your fork, it will be in your own repository. Okay? So you can see over here, you can see that, oh, it is this is your repository name, and it's forked from this particular place. Okay? So over here you can see that, oh, this branch is now up to date with this what we call upstream, because it's upstream lah, in the river it's upstream. So it's now up to date. And then if let's say this particular Exosoft repository updates, you can always sync your fork here, but there's no new commits for now. Okay, all good. So once you make your own fork, you open 𝐺𝐿𝐴𝐺𝐿 over here, and then you can choose to clone a repo. Okay, a clone a repo means that you make a copy, and then 𝐺𝐿𝐴𝐺𝐿 is very smart. It automatically helps you link everything. Again, if you're using manual Git, you will need to specify the origin, you will need to say who you are, you will need to say your email address, so and so on. Okay, so you clone a repo here, and you can clone with URL like this, no problem. Or you can go to github.com and just use the existing integration. So for us is the learn Git with 𝐺𝐿𝐴𝐺𝐿 repository. Okay, and then now it will let you choose the location where you want to clone to. Okay, all good? All good? Okay, and then we clone the repo. Okay, sometimes in 𝐿𝐴𝐺𝐿, right, actually, you will find out that you can't access GitHub, you can't push, you can't pull, you can't clone a repo. Why? Blame PPPK if that happens, because they tend to block SSH. GitHub sometimes uses SSH to connect with each other, and you know, if you're not lucky, they use SSH and you can't use SSH, and they block it. So yeah, blame them. All good? All good? Okay. So As you can see here, there are already a few commits here already that is done 3 years ago. So we have initial commit, we have all of these different commits here. So let's just talk about the interface first, okay? So the interface here, we have a local that shows all of your local branches. Yeah, because you can see here, this master, okay, has my icon on it, which means that it's at a remote. It's my remote, okay? It has this little computer here or little laptop here. It means that this particular branch is at my laptop, my computer, okay? So you can see branch B and branch A, there's only a tag on GitHub. It doesn't have a tag locally, okay? It means that this branch is not here yet. You can make it here lah. Okay, so local, as you can see, there's only one branch. Remote, you can see in origin, they have branch A, branch B, and master, as you can see here, different icons. So in more corporate environments, you can probably have multiple remotes. It's also something very common. Okay, pull request. So pull request, I'll explain it later on. It's also one of very important things, and issues, teams, tags like I say. How do you make a tag? It's basically you select one place or just select one. Right click, just create a tag. And that's it. You can say, okay, it's a V1 and created. So this V1 actually only exists in my local laptop. Okay, I will need to right click it and push to origin. Okay, all of the changes you do in the end must push to origin. Anything that is not pushed to origin means that you didn't do it at all, because no one has access to it. So you can push to origin. You can see it pushed successfully. Okay, so now we have done forking, we have done cloning. Let's do editing. Okay, so how do you do edits? Of course, you can access it using VS Code. I use VS Code. And then in VS Code, you open your folder. Sorry, this is my existing project. Let me close everything. Okay. Nope, yours shouldn't show like this. Okay. Okay. Open folder. I have a lot of plugins, so apologies. So open a folder. Yep, this is what you should see. You open a folder. You go to where you duplicated the stuff, where you clone the stuff. Okay, for me, I throw everything in Git code here. And then learn Git with 𝐿-𝐴𝐻𝐿. Then you select the folder. And then it will open in a bit. Okay, so those of you that don't have VS Code installed, you can always use Notepad. Okay, for demo purposes, you can always use Notepad, but VS Code is because it has nice linting. You can see all the colors, different colors here, and that's it. You can use Notepad++, anything, as long as it is a a text editor, then you can pass. Okay, everything nice? Now you just open this index.html file. You guys open index.html file? Open it, Notepad, no problem. Okay. Okay. Now from line 40 to 48, you copy the code and paste it down here. Okay. You copy this from line 40 to 48. You paste it from line 50 onwards. or actually down there also can. Doesn't matter, but yeah, the point is you copy and paste the code. Okay, done. So you can make your changes. You make your name. You can write your name here. Let's say Quang. Okay. For others here, you can choose to edit, not edit, your choice. All good? Anyone need assistance? Please raise up your hands. Oh, this is too small also. And also, I think I need to clarify, there's a big difference between Visual Studio and Visual Studio Code. Visual Studio is what you call an IDE, which is a very complete set or suite of tools that helps you on your programming. But Visual Studio Code here is just basically a text editor slash code editor slash whatever you want to call it. Okay, so uh, yeah, you can imagine that Visual Studio is a big cruise ship. Visual Studio is Visual Studio Code is like the chef only, or just one small department. All good. You can copy from line 40 to 48 to somewhere around here or here. Yeah, it's here. All good. 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 Okay. So, um, one thing I forgot to say just now is remember we have this thing called branches, right? It is a very very bad practice, right? If you're working on a team and everyone commits in the main branch, what will happen is, uh, you know those kind of big car accidents, those will happen every day. Okay, so what we do here is in GitKraken, right? We click on the commit we want to start to do a branch on. Okay, so right click, create branch here. Okay, you create a branch, maybe call it demo one. Okay, so now you can see this particular commit has two branches that is basically tagging here is demo one and master. Okay, click on the commit, right click, create branch here. Then you create your branch. Okay, all good. Yeah, it doesn't matter whether you edit first or you branch first. That the chronology does not really matters because the point is you haven't commit. Okay, all good. Now let me continue. Okay, so as you can see here, this particular branch, it only exists in my local computer. You can see this little laptop here. Okay, never mind. So let's go back to our this index.html and let's save it. Okay, so once you save it, you get back to 𝐸𝐿 and you can see that there's this WIP, which means work in progress. Okay, so you click on it and you can see that there's an unstaged file here. Remember our chronology on untracked, unstaged, staged, and committed? Oh, modified, sorry. Yeah. So what happens now is that this particular file is now modified, and now let's stage it. You can see stage file here. You can click it, or you can click into this file here, and you can see the changes here. Okay. Green part means you added. Okay. Green part means you added. So for example, let me just randomly delete something and save it. You can see that there's a red part here. Okay. This is delete. This is add. Okay. And there are different types of views in 𝐸𝐿 to help you. So for example, this is div view. You can see in file view, which means all of div view, and then you can see in inline view or split view. So inline view basically makes everything in one whole file, and you can see from here like this. Or you can do split view that compares it side by side. Okay, so each kind of view serves different purposes. For example, if you are doing a major refactor, then split view will be useful. If you are doing small changes, then hunk view, which is this, will be useful. Okay? Everyone okay? Okay. So, um, the good thing about GUI is that it lets you very easily select what you want to commit. So for example, this particular commit, I don't want it. At least I don't want it now. Okay? I can choose to only stage this particular hunk. Okay? So now you can always click into stage files here and you can see that, okay, this is what will be committed and this is what will be pushed. Okay? So from stage files here, you can see what is being committed, what is being pushed. The good thing also about GUI is that you can select only one line to commit. For example, you can say stage this line, stage this line. I don't want the rest. So what happens is this. You can always do that. But in today's demo, let's stage this down here, this particular hunk here. Okay, this is what you will see in the stage files. Okay, all following? No. Okay, let me say it again. So over here, you can see that there's a work in progress here, and on the right here, you can see unstaged files. So unstaged files means that things that will not be committed on my next commit. Okay, so what happens is you can either stage the whole file, which means that I want to commit the whole file, all the changes, or you can choose to stage a hunk, which means I only stage this section, I stage it, and that's it. So these changes, this deletion is not being saved, whereas this particular addition is being committed. Yeah. Okay. Lost? Not lost? Following? Okay, so let me just continue. Okay, so in coding, it is always a good practice to assume that everything will be read by other people many times, especially in the corporate world. But your group project, never mind lah. So in commit messages, we can put up a summary here. So for example, this summary will be, let's say, add bio. And this description can be anything, or you can leave it empty. No problem. The most important thing is actually commit message here. So you can see it from outside. You can see all of these things outside here are commit messages. These are commit messages. Okay? So once you're done, you commit changes to the file. Okay? So you click on it and you can see now I'm here. All good. Okay, so for those that accidentally open or purposely open it in Visual Studio, uh, there will be multiple automatic generated files. So those files will start in .vs. You can just ignore them, and you just stage and commit index.html. Okay. So this is actually a very good exercise because you will need to always be clear and remember what code are you saving right now. Okay, so I get everyone is on the same page now. So you can see that this particular laptop here, it means that this uh, this branch only exists here. So how do you make it exist in GitHub? Okay, so what you do is push, and then it will ask you, okay, which remote branch should this particular branch on your local computer push and pull from. So I usually will use the default and just click submit. So it will push and it will tell you push successfully. Okay, so now to verify it, go to GitHub. Okay, remember this repository that we push just now, that we forked just now. Refresh the page, and you can see from the branches here, your demo 1 branch is now here. Okay, all following. Okay, so those that are following, I don't want to make you so bored. So let's just click on demo 1 and let's just see. You can see that this particular demo 1 branch is one commit ahead of the master Exosoft master branch, which is our master branch also lah. So from here you can actually see that if you change this thing, you can see different versions of this particular code. So for example, let's go to branch A, which is the initial commit, and see. Okay, let's say index.html. We have all of this. Okay, sorry. Yeah, I assume initial commit does not have anything, but seems that it have. But my point being, if you change this particular switch, if you switch branches here, right, you can see what the code is at that particular branch. So it's a very common thing. For example, like I want to make a new feature. For example, my app is WhatsApp. Okay. Now I want to enable WhatsApp to do VR call, for example, virtual reality call. So I make a new branch. It's called VR. So I just do all my changes there and blah blah blah. It does not affect the main app, right? So once it's done, maybe I tell my senior that okay, my code is done. Please take a look at it, and they can choose to merge or reject it. Okay, so you're now at master branch, right? Okay, so for demo purposes, let's just assume that someone edited index.html. Okay, so you can click into index.html here, and you can see all of this. So for GitHub, right, you can actually edit code online. You don't need to download GitHub or you don't need to download Visual Studio or anything. You don't need to fork it. You can just edit it online. But it is quite a bad industrial practice. Why? Because usually if you download VS Code and you install all the dependencies, right? Usually you have this thing called linting, which means that all this thing automatically format your code to make it adhere to corporate standards. Okay, so for the sake of demo, okay, let's edit this file. Okay, yep, let's just edit this file, and then wait, oh sorry, make a branch first. Sorry, you all branches here, and then over here you can click on the new branch. Okay, new branch. This name is called demo2. Okay, and create branch. Now you go to your code here, and you edit this demo2. You switch to demo2 branch. Okay. So when you go to demo2 branch, you go to index.html. Okay, remember the file just now, index.html. Okay. Now let's edit it, which is this little button here, this little pencil button here. Okay. So remember we did changes. We copied the bio just now. Let's do it again. Okay. We copy this and then we paste it. So if just now you paste it in line 50, then you paste it at line 50. If you paste it at line 52, then paste it at line 52. Okay. So now edit this line, this H2 line here, to something that is not what you changed just now. So for example, just now, my changes are, I make this 𝐴𝐭𝐞 like this. So maybe now I put it 𝐴𝐭𝐿123. Okay. Or you can just edit anything here, blah, blah, blah. And that's it. Okay. So once you're done, all following. Okay. Once you are done, commit changes. And then the commit matches it will automatically generate for you. So let's just directly commit it. Okay, now we have two branches, but let's switch back to our 𝐺it_Kraken. Okay, 𝐺it_Kraken will automatically update. So sometimes, right, Git Kraken does not automatically update, so you will need to fetch all, which is here. So basically, fetch means that from remote, all of your branches, all of your changes, give me a copy. If I have a local branch, I don't touch it first. If let's say you decide to make a pull request, if you decide to pull it, then my current branch will be synchronized to the branch at origin. Okay, I know it sounds messy right now, but once you do this a few more times, then everything will be clear lah. Okay, so let's inspect it for now. Okay, so you look at add bio here, remember? We edited lines 52 to 60, right? You see this particular update, also line 52 to 60. Okay, it's different content. Okay, so let's just put our brain aside for now for this one, and let's talk about this thing called a pull request. Okay, so usually once you finish your so-called changes, right, your code is ready to be reviewed, then we will do a pull request. So what does a pull request mean? So a pull request in the context of GitHub means that I request you to pull in my changes. Okay, I request you to pull in my changes. That's why it's called a pull request. Okay, so in GitHub, click on new pull request, and this example, okay, remember to change this base repository to your own repository, because otherwise you will risk polluting the main repository. Okay, so now you will see that it compares changes, but which branch you want to pull from. Let's say demo 1. Okay, so you compare the changes between master and demo. So you can see this particular arrow here. Okay, this particular arrow here, it means that demo will go into master. Just remember it like this. Demo 1 will go into master. This is how this arrow works. So from here you can see it gives you a quick summary. It gives you a quick summary that says that, okay, this demo 1 has one commit here, and these are these particular changes. Okay? Yes. Okay. Come again? Oh, too fast. Okay. So, are you guys on here? No, not yet. Okay. Let's do this again. So pull request, right? Pull request tab. Okay. Now what you want to do is you want to make a new pull request. So new pull request. Okay. Click on it. And then you change the base repository here. Okay. This base repository, you change it to your own. You change it to your own. You click on it, it will tell you, okay, there's nothing to compare. And then you change this thing here to demo 1. Okay, all good, all following, all following. Okay. So from here you can see that there are different commits here. You can see what are the changes since master branch, and then what are the changes. Okay, so once you are okay, click on create pull request, and then it will let you say something, leave a comment, assign yourself, blah blah blah, and then you can create a pull request. Okay, so this is pull request number 1. Okay, so what this pull request does, is basically, of course, like I said just now, I request you to pull in changes. Okay, from where to where? Into master from demo 1. You can see it. Okay, into master from demo 1. So, of course, your senior will probably take a look and say, okay, leave a comment. Looks good to me. Without saying anything, without probably looking at your code. And then you can always merge the pull request. Okay, so you can just click on it, confirm merge. Yay, it's merged. So you can see the status changes. And over here, 𝐸𝐿𝐴𝐵𝐿, you can see the changes not yet propagate yet. You can always, okay, it's propagated now. So you can see from over here, what your pull request does is it basically takes demo 1 and it merge into here, right? Okay, it takes your commit, it merge it in. So what your commit is you edit index.html, it merge, edit index.html. So it basically just merge your changes back into a main branch. So what happens is that, let's say your group members, they can they can base their new changes on what you change. Okay, all good, all good, all merged. Okay, now something happens. You and your group members change the same file. Maybe you guys change the same section, right? So remember just now I asked you to update index.html at 2 places. Remember that? So that is to simulate that. So let's just say we want to check out demo 2. So what checkout means is that all of my changes are now on this branch. I want all of the code in my computer to be this version, which is this branch. Okay, so you can come to demo 2 here, right click, just now remember the changes, you can always discard everything to make it clean. Okay, okay, now master is here, okay, master at remote is here, but master at local is here. So what we do is we check out the master branch, we click here and click on master, because master branch is already on our computer. We click on it and then we pull in the changes that we did just now. So we pull, okay, pull. So now you can see that this branch is now updated to this particular commit. Okay, this branch initially here is now in this latest commit. Okay, so now let's simulate your poor little group member. Okay, your poor group member is now at demo 2. Okay, so how do we simulate? Let's just right click demo 2 and check out. Okay, check out origin demo 2, and now it will automatically make a branch. Okay, this is something 𝐸𝐿𝐴𝐵𝐿 specific. In normal cases, it won't automatically create a branch for you. Okay, so if let's say later on you graduate to use CLI, remember this is not a default operation. Okay, so now your group member say, hey, there's a changes in the master branch. So let me pull the changes in such that I am editing based on those changes. Am I right? All get what I mean? So 𝐸𝐿𝐴𝐵𝐿, there's this very intuitive operation. Master branch here, you click on it, you drag it, okay, you can drag it, and then you drop on demo 2. Which means that master we now merge into demo 2 branch. So now you merge master onto demo 2. Okay? If I am correct, you will see a merge conflict. Merge conflict. Merge fail. This is expected. Don't panic. Okay. This is expected. Okay. So what is a what is a merge conflict? So you can click over here, conflicted files. Okay. Remember just now we did changes. One, we say that the bio is 𝐴𝐚123. The other one is 𝐴𝐚 without 123. So I did a change. My group member did a change. Who is correct? Okay, who is correct? So, for example, you can say that okay, demo 2 is correct. So I click it. So down here, it will give you a preview. Okay, down here it will give you a preview. Or you can say that okay, master is correct. You click it, and it becomes this. Or you can say that I am both correct lah. Click both. So one will be on top, one will be on the bottom. Fair and square, right? Okay. Okay, I know this one you guys, some of you probably will get burning, right? Okay. Everyone still with me? You got your gate conflict? You got your conflict? No? Yes? Yes. Everyone got conflict? No? Hey, serious. You haven't got conflict? Oh. Okay, let's continue, I guess. So, um, over here, you have a conflicted file, and then you can check, you can tick on which changes you want. So, for example, I want both. So, I just click on both. And actually, I can also choose that, okay, I don't want this particular line, like this. So no problem. If I regret, I can add this line back, like this. Okay, so now we save our changes, and you can commit and merge now. Okay, commit and merge. You click, and you merge. And the next thing after you merge is, of course, always push. Okay, so once you push, you can see now demo 2. You click on this code, you look at demo 2. Okay, index.html here. You can see that our changes are here. Okay, okay, so actually this is the end of the demo. This all of these changes, right, will basically take you to finish your uni to your workplace. Yeah, GitHub and Git basic use is like that. Of course, there are a lot of other different features that you can use, but as of now, as of your project, your FYP, this is good enough. Okay. Okay. Remember just now I said something about commit hashes. You can actually access your commit hashes here. So what this does is that it gives you a signature such that the next commit will take this commit, it will take the signature, add towards that commit to make a new signature. Sounds familiar? It's blockchain. It's blockchain. Okay? You have this, for example, I take this one. This commit is 78A8FB. Okay? So the contents of this commit actually includes this particular string, okay, together with the changes that is being done to make this new string, to make this new hash. So each commit is dependent on its previous commit, and this is what we call a blockchain. Mm. So IR4, blockchain. Okay, so I think probably let's kind of wrap up. Okay, okay. So best practices. Okay, again, Git is very powerful, but if you use it wrongly, you will harm others. Definitely harm others. Okay, so do for team leads, I personally recommend you to lay out boilerplate code. So for example, if you're using Visual Studio, you will have some automatic generated files. You can commit those or not using a git ignore file. Or for example, you have a C++ program, for example. So you got main.cpp. So you as a group member, you make group leader, you do that main.cpp, and then you put some functions for your group members to fill in. This is the recommended way of doing lah. And then the next thing is, remember to format your code before committing. Always format your code. Why? Because for example, my laptop got auto formatter. Your laptop, no auto formatter. You don't format before you commit. When it comes to my laptop, right, it will auto format everything. So what happens is later on when I trace it back, I won't know who did what when exactly. I will only know, this guy got auto commit, and that's it. It is very bad for traceability. Okay, next one is to pick your stage code every now and then. Remember just now when I demoed 𝐸𝐴𝐽𝐿, you can stage a chunk of the code. Yeah, so this is it. You stage a chunk of your code. You don't need to commit everything, but the point is you will have multiple different checkpoints, okay, that you can go back if anything goes wrong. And of course, committed code, best practice should be directly workable, but in common practice, this does not always happen. Okay, even I don't really adhere to it. And then the next one is very important, is to use commit messages that make sense and keep your branch up to date. So what do you mean by commit messages that make sense? You don't put a commit message that say update code. That's it. No, no one does that. You of course you will say, okay, I add a button, I center the div, and so on, so that you will be clear on changes. Next thing, don't commit binaries like what I said just now, and don't commit generated files. So we have this thing called git ignore. Oh yeah, I think I missed something in the demo, but okay. Don't alter history. Throughout your Git experience, right, you will definitely face something called a force push. You will know something called a force push. Don't do it, or if you do it, make sure probably you are the only maintainer in that branch or that repository. Why? Because when you force push, you are basically saying that, okay, ignore everything now at GitHub. My one is the correct one. I don't care. My one is the correct one. So what happens is, if you force push your code, right, you will possibly wipe out your team members' progress because they are doing the changes, and then suddenly you force push and say, don't care about their changes. Mine is the correct one. So this is a bad one. And next one is what we call a commit secrets. So what is a secrets? Is database passwords, for example. Anything that is passwords, keys, hashes. Okay, hash maybe not that secret, but mainly what we say is passwords. For example, your database connection and so on. Because there are people that run bots to scan through GitHub to find secrets, and they can just hack it. It's easy. And when you use Git, don't panic. Yeah, when you panic, you will start to commit all rubbishes, and then in the end, you will most probably force push. So most importantly, don't panic. Okay. Now, in many environments, we have this thing called a Git flow. This is actually also just a best practice. So we have stable branches, which is a master, develop, release, and so on. Volatile branches feature something like, I want to add a VR call to WhatsApp. This is a volatile branches. So volatile branches can be a big branch or can be a small branch, like center the div, for example, or fix this particular bug. Okay, so again, for team leaders to boilerplate code, you can protect the main or master branch in GitHub actually. So let me just demo how do you protect it. Okay, so get back to your GitHub repo here. You go to settings. Okay. Over here, code and automation section, there's this thing called branches. Okay, you can see that you can always add a branch protection rule. Okay, so for example, my branch name pattern is called main. Okay, wait, it's called master, sorry, because it's this thing. And then I can say that, okay, I can always require a pull request. Anything that comes in needs a pull request. Don't merge from outside. I can do that. I can require signed commits. It's a very cool thing that is not in the scope of this talk. You can lock branch so that people cannot push to the branch. Also can. And then by default, if you lock down a branch, right, it won't allow force pushes or deletions. So yeah, so you can see master branch here. and then you can create. Enter your password, and that's it. So anything that you do, you cannot force push. So let me just make a demo here. So let me check out master branch here. Okay, let me check out master branch and say that, okay, I don't want all of these changes. I want master to be here. Okay, so right click, I can say reset master to this commit, and I discard all the changes. Okay, so now I can right click here and I say push. But now, since it is behind the origin, I can choose to fast forward, which means I update my current branch to what is in the origin, or I can force push, right? Force push, yay! And then it's a destructive action, it will warn you, definitely. So now you force push, it will reject, because it's a protected branch. You cannot force push. It will just block you off, okay? So if you are a group member, a group leader, please do this to your main branch. Definitely do this to your main branch, because when your group member panic, then they will start to do force pushing. Definitely. Always happens. Okay? Even in the corporate world, it also happens. Okay, now just now there's something I missed in the demo, is creation of a repository. In GitHub is very easy. You just click on the new tab and you just create a repository over here and just select GitHub. Okay, so over here you can initialize a repo, which account you want to use, your name and so on, who has access. But remember, GitKraken only gives access to private repo if you pay. So for public repository, you can use GitKraken. If not, use other tools. And then where to clone to, where is it? Okay, this thing, very important thing, is called a git ignore. So what a git ignore is that it tells Git to ignore some specific files. So for example, if you are working on a C++ project, maybe you don't want Git to record like .exe or something in the builds folder. So you declare in the git ignore template. Okay, and then license here is, I would say, something important also. Why? Because when people see your code online, maybe lah, they will say, okay, this thing is very good, let me make a copy of it. How do I make a copy? Should I give you credits? Should I not give you credits? If let's say your code made my computer explode, can I sue you, and so on and so forth. So a license is good to have, not exactly must have, but it's a good to have. So once you're done, you just create repository and clone, but I won't do it here now. Okay, so like what I said just now, there's this thing called a git ignore template. So let's just, I'll just take one of my projects. Okay, so my project has a git ignore, .git ignore here. So what it does is that it will ignore all of this. It will ignore PyCache, it will ignore build, it will ignore all of these folders and so on. So there is a public repository in GitHub that gives you the best practices git ignore for each for each framework, programming language, and so on. So for example, let's say we want to ignore something that starts with anything. Over here you can see this star that ends with egg, egg. This format is very common for Python egg files. Okay, so let's, for the sake of demo, let's make a new file. Let's say test.egg. Okay, so when you see in source control here, you can see that it does not list this test.egg anywhere, because it ignores it already, right? It just ignore it. This file, I close my eye, I don't see it. So usually what we put in git ignore, these build things, and also we call it env file. environments file. What is in the environments file is usually your secrets, your database strings, your passwords, and so on. Usually these will go in the environment. So for example, don't worry, this is like deprecated. But yeah, so for example, your database password, your secret key, your traces, and so on. So all of these, we put it in env files. We don't trace it. Okay, so we settle this. Okay. Now, yeah, don't directly commit. You as a group leader, don't commit to main branch unless it's really absolutely necessary. You need to fix something really emergency. Then only directly commit. And of course, the next thing is to use Discord or webhooks to receive notification about changes. When you do changes in GitHub, you can actually hook it to your Discord, for example. So, for example, I got my own little channel here that says, okay, this particular project, for example, okay, this project. So, any changes, it will push to my Discord channel. Okay, so let's demo. Okay, now you go into edit channel. Remember, you will need to have permissions to create webhooks. Okay, so over here you can see integrations and webhooks. Now you create a new webhook here. Okay, and you can see that you can copy the webhook URL. Okay, you copy the webhook URL, you come into settings of your repository, and then webhooks. Okay, so webhooks, it allows external services to be notified when certain events happen. It does not limit to GitHub only, Discord only. So for example, I run a Kubernetes cluster. If there's any changes, it will automatically update that cluster. Okay, so you add a webhook, payload URL here. Okay, you paste it in, and then you / GitHub. Okay, content type, I think it's JSON, and then send me everything, enable SSL verification, and add. So you can see this is now triggered, it's now testing. You can see recent deliveries. Okay, so you can now see that the ping request is success. Okay, so let's try something. Okay, so let's get back to our demo here. Wait, let me just make a change here. Okay, for example, I change index.html. Okay, index.html, I simply make a changes here. La 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 la. I commit changes, and that's it. I commit directly. By right, I should have received this. See, one new commit. Yay! Okay. So this thing is actually very useful when you are dealing with a lot of different group members, or you have group members that are very lazy. This is one of the ways lah. Okay, now I've demoed us using Discord webhooks to receive notifications. Okay, now for team members, always branch from latest version, and of course, as a best practice, merge latest changes from code before submitting your pull request. And then if let's say the main branch has been updated, you can always re-pull again, such that when your senior or your superior merge it, they can directly merge it lah, without needing to wait you to merge your code. To solve the merge conflict of your code. Yeah. Okay. And of course, one branch for one new feature. Don't do everything in one branch. Remember to branch out, such that if anything breaks, it only breaks at that particular branch. And of course, always format your code before committing, or else risk your contribution being taken, like what I said just now. So again, if you screw up in Git, delete your local copy, download fresh copy, and that's it. If you don't know what to do, delete everything, pull, done. Okay, this is the good thing about Git. Okay, now GitHub as a portfolio. So in GitHub, you can see that you can see github.com/ your username, and then up here you can pin all of your projects that you are proud of, and then down here are your contributions in the last year. So if let's say you are applying to jobs and so on, right? Maybe some recruiters will see this place and say that, oh, you got so many contributions. Okay lah, can lah, this person, and this person, you can prove to the recruiter to say that you know how to use Git, because this is actually a minimum requirement for many jobs. Some of them don't even accept you if you don't know. Yeah, so you can analyze your activity. You can say that, okay, how many percent is commits, how many percent code review, and so on. And then you can create your own front page. Of course, not in the scope of this talk also, but you can make a very nice page lah. Okay, so how to make a profile shine? Yeah, sure. Now we have aircon. Terima kasih, bang. Okay, so how to make a profile shine? Because recruiters are generally looking for proof that, one, you are passionate about programming, because you have those green little dots. You have a diverse skill set, because you deal with different programming languages, you deal with different projects, and you have the skills to actually solve problems. Because remember, when we deal with Git, we have a trail. We have a history trail of what you did, what when. So from there, you can prove that, okay, you are being able to solve problems in organized ways on your own. Yeah. So again, why is this talk more about how to use Git? Because you need to prove that you are able to work in a highly organized manner. Companies don't have to deal with you doing Git push force every time. This is actually very common, you know, like my friend, he's working, he has a group member that keep on doing Git push force, so they had to deal with a lot of different things that happen lah. Okay, and then seniors can focus more on doing their work instead of helping you to fix stuff, and you can focus more on your work instead of fixing your stuff. Okay, and then yeah, like what I said just now, it is a clear way on how you think and approach problems. And then being a senior programmer, from GitHub you can see that, okay, we will gauge you how you structure your code, and then if your code is messy, then we will know to reject you, because when you are a senior already, you are much more harder to influence, and if your code is messy, most probably you are too, especially when you're up to a senior position. Okay, now next thing, make sure your teammate contributes. Say no to sleeping members. Okay, this is very interesting. Why? Because in GitHub, right, there's actually this thing called GitHub Insights. So we have a contributors tab and a network graph. So let me just show. Let me just take a public repository. Okay, for example, this strawberry GraphQL Django. This one is one of the projects that I help on. So from insights here, you can see that, okay, there are a few pull requests, active issues, who added what when, who are the contributors. Okay, it will crunch all the data, and from here you can see, let's say in this particular time, who did how many commits, how many lines they added, and how many lines they deleted. This is a very strong evidence when you want to report your teammate. Yes, so this is how I made two of my team members get C, but yeah. Yeah, but this is one of the ways lah, because if you don't use Git, right, you can't trace back anything. You can only just screenshot WhatsApp messages. But this one, just trace and that's it. Okay, you can trace by commits, you can trace by additions, you can trace by deletions, your choice. And then over here you can see, okay, the commits is how like how is the frequency and so on, your dependency graph, your code frequency, and so forth. So there are these are the evidences lah. You can give your lecturer. Yeah. So this, and then Git blame is a feature that you now know who to blame if your code screws up. What do I mean? Okay, for example, in this particular index.html, I click in and I can see this blame. Okay, so from this view here, I can see that, okay, this particular person authored by me, I change here. Remember I changed here just now? Okay, I over here there's this particular guy that did this commit called testing workshop that changed this particular section. I did this add bio here at this particular date to change here. So git blame is a very good way to trace back the reasons why this code is changed and who changed it. And okay, almost the end of it. Thanks for bearing with me. Let me just summarize with some takeaway points. Okay, first, Git solves many software development problems by providing distributed version control service. Git is the version control software. GitHub is the website. GitKraken is the GUI. Okay, remember to separate these three in your mind very clearly. Okay, terminology, repository, where is the code, remote, a repository that is not on your computer. Branch is like a tree branch. Commit is basically a checkpoint. A fork is a type of branch, but you are making a copy of your code, of this particular code on your place. So we call it a fork. So git ignore is a file that tells Git what to not track. A pull request is you request people to pull your changes in. So if I remember correctly, pull request is quite GitHub specific. Yeah. In some other softwares, they call it a push request, they call it a merge request. It depends on what software you're using. Okay? And then a stash is where you can store your code. So for example, just now, I think some of you face the problem that when you check out some other branches, right, it will have some conflict and then it helps you stash it, right? So a stash is where you can store your code temporarily, and then when you need it, you just pop it out, or you just apply the changes. So this is a stash. So give flow workflow to track files, stage it, commit the file to snapshot it, stage your changes to be prepared to be committed, and remove the file to untrack it. So this is a very simple cycle. Okay. Some public service announcement. I think I still got time, right? Got time? I still got time? No time? No time. Okay, never mind. Free stuff. Just because you're a student, you can actually register for the GitHub Student Developer Pack that gives you free GitKraken for private repositories. That's it just now. I think it's for 1 year, and then you need to renew again. But since UTM does not cancel our email addresses, you can actually keep on requesting for it lah. And of course, we got Azure DevTools for teaching that gives you free cloud resources. For me, I'm now using 100 USD per year. Yeah, for free. Okay, DevTools for teaching. And references, if you're interested, there's this 500-page book about Git. It's called ProGit, and this book is hosted in GitHub. And also, you can learn Git branching. This is a very interactive way on how to use the command line to learn Git. And of course, many of our resources that are used today, the images and stuff, is from this website by Learn Git from Atlassian. So Atlassian, I think they do GitLab if I remember correctly. Right? No, they do Jira also. Yeah. So we are hiring if you're interested. So 2,000 ringgit intern, fresh grad 3,003 above, fully flexible work time, work anywhere. You can find me. Yeah. Yeah. So now we are lacking of people to work on our projects. So yeah. Let's go to a Q&A session. How do I go to Q&A? Is it this? Q&A. Why do we need to do branch in GitHub? I think I answered that just now, so that you can have different changes at different places lah. Okay, and you can develop in parallel. Yeah. Okay, what's the difference between GitKraken and GitHub Desktop? GitKraken is, I would say, it's more of a paid product. It has more features than GitHub Desktop, and also GitHub Desktop only supports GitHub, as far as I know. But GitKraken, they support you closing pull requests, closing what we call the Jira tickets. They support GitLab, they support Azure, and so on. So for me, GitKraken is the superior one. Also, it gives a very clear view of your branches. GitHub Desktop does not. This is why I chose to use GitKraken for my starting days lah. But you know, you will eventually graduate from it. And then in IT field, how GitHub profile really helps for seeking jobs, I think I answered that just now. Any questions from the floor? Yes? No? Okay, then I think this wraps up my session. Thank you all guys for listening. And if you guys are interested in the extended session later, which I think will happen 15 minutes or 20 minutes after the end of this session, do stay back. Yeah. The extended session also very interesting. I will talk about GitHub Actions and GitHub Code Spaces. Who is the MC? Who's taking it over from me?
Okay, for who not yet take attendance can take your attendance now. Maybe 3 minutes. Can. Can. Cannot go to eat shit already. Everyone already take? Who not yet? Done. So next slide. So you all can take your SMP mark. For UTM students, select Pelajar UTM, and for non-UTM students, select Penghujung. So maybe 3 or 4 minutes. And for last, we need take your feedback. So can you please scan this? Can you guys please scan this QR code? Then we need hear your guys' comment for this event. Then after that I will invite Tanjibin to intro our next upcoming event for our club. So
Hello, my, my name is Tan Zibin, and the next upcoming events for the GTSC is introduction to the Go programming language. So the Go programming language is a programming language. Then it is the is using the simple structure and is got a high performance to you to develop a system. It is a very useful programming language. So if you're interested, you can scan the QR code to register. And if you want to know further about the Go programming language, register. Thank you.